Hello guys, welcome to the new series of data structures and algorithms. As a part of my YouTube journey, I just want to start this new topic that is related to data structures. So, as you know that previously I have done some tutorials on C programming to get a basic, understanding about the programming language. From here, we will try to learn things related to data structures and algorithms, mainly for problem solving. Basically, this kind of series is mainly meant for your technical subjects, like you might be having data structures and algorithms, right? So in order to get a good grip over that, you can see these videos, as well as if you are preparing for interviews, or if you are at your final year or at your third year, then definitely these videos will be the most beneficial for you. It's not like uh, only for third years or fourth years, but for complete beginners also, this series is going to help a lot. So try to follow my channel. Please try to subscribe this channel so that it gives me a lot of motivation to provide further more videos. Like we will try to cover as much as possible, like complete data structures, arrays, linked lists, trees, graphs, different algorithms, and different topics such as backtracking, dynamic programming, and there are many things, right? So we'll try to cover each and everything in detail with examples, and you can see a different explanations here. It's not like a typical things that you are going to see in other channels, or in your colleges or something. You can get a complete different grip over here, like you can understand the intuition completely, and you can solve everything on your own. So as I said, it will be a good start for you. And whoever seeing this video, firstly thank you for watching. Try to watch this video till the end. It will make you it will give you a lot of things to learn about. So as a part of this first video, firstly, data structures. Why do we need data structure, right? Before going to know why do we need this data structure, firstly we need to know computer, right? So we know that why computer is invented, to make the things easier, right? So whatever applications, or whatever the software applications, or whatever the hardware that you have in computer, these all things are required, right? In order to to function a computer properly, these things are vital. So as a part of that, you have seen programming, right? How to program, like how to write a code. You have seen many codes, like assembly level code, or some high level or low level languages, something like that, right? Basically high level in the sense, you can see, we can write it in our own understanding. If it is low level, then it's something that is completely related to computer, right? So as a part of it, data has been a important thing. Wherever you go, we definitely need that data. So in order to store that data, you need something, and in order to access that data, you need to do something. So store and access, two important things have come up, right? So data structure, that means we are doing something to store this data in a structured format. It's not like we are storing it randomly in some book, or randomly in some box or something. We are storing it in something, but in a structured way, right? So that is about the data structure, right? And algorithms. Algorithms, a basic definition of algorithm. Like the functionality of algorithm is just to provide a piece of code, provide a sequence of code, so that it performs some particular task, right? So that's a simple definition for algorithm, right? So let's try to move into the next slide and try to know something in detail about it, right? So firstly, agenda, like what we'll be covering in this video. As a part of this video, we will cover the data types, we cover the representations, we cover the range, and we cover some of the operators, right? You may find it surprising, or some of them might find it new, but let's try to make it easy, right? So firstly, talking about uh, data structure, as I said, right? The name itself, it tells you the definition, how you can store that data in different structures, right? Structure in the sense, it's a proper format. It's not like you take it however you want. You want to store it, or line wise, or it's like crosswise, or some different zigzag wise. So there can be different orders, right? So you want a structured one, that means a proper one, right? So that's the main idea of data structure. You want to store it in different structures, right? And algorithms is simple. You're writing some piece of code, like you want to solve a problem. In order to solve that problem, you're writing a piece of code such that this piece of code will have to do something with this data. So again, I'm repeating, algorithm is nothing but you're writing some piece of code, and that piece of code is doing something with this data such that that piece of code will try to solve any real-time problem, right? So that is a basic one of algorithm. It's just a code that you write. It's just a task or a sequence of instructions that you provide to your computer to solve this task or to solve any problem, right? And there can be multiple solutions for that problem. That makes sense, right? For a particular problem, there is nothing like you just want one solution for it, or you are having just one solution for it. There can be multiple solutions to that problem, right? So those multiple solutions, we can also call it as multiple algorithms. So you can have multiple algorithms to that particular problem. So that is some basic definitions about the data structures and algorithms. Talking about the data structures, basically there are two types of data structures. You can say primitive and you can see abstract, right? Basically, as a part of data structure, we would focus more on this abstract data structures. Like you can have some subtopics under it, like many things to learn. Of course, primitive is a basic thing that you are going to use in your programming, right? You know what is integer in programming. If you have seen my earlier C programming lectures, you would definitely know what are primitive data structures, and you have a good command over it if you have watched them. So int is an integer. Char in the sense it's a character. It's a data type, right? Float, floating point numbers. Bool, boolean. It's like true or false. And you have double. Some more decimal places than float, right? So that is about the primitive data structures, right? Talking about the abstract data structures, these are the important ones. We are going to focus in these series of data structures a lot on these things, right? Arrays, you can have linked lists, you can have stacks, you can have queues, etc. So just in this in this video, we will try to recollect some of the things related to primitive data structures, like what is an integer, what's a character, why we are using it. Integer in the sense, if you want to store some integer data, then you need an integer, right? If you want to store data which is of a decimal value or something like that, you need a float, right? If you have a floating point number, simply you will use a float. Suppose you want to store a single character, like you want to store a character A, then you need char. If you want to store something like true or false, like you want to know if this is something, then it's true, then if not, it's false, right? So if you want to store something like that, you can use bool. And double, as I said, some more decimal places than float, right? And you have long double, which is greater than double, right? You have much more decimal places for it. So you can have short, which is less than integer, and you can have long, as well. It depends, right? If you are using a programming language such as C++, you might not, you might mostly see this long, but as a part of Java, you cannot see this long. You can see long, but mostly you won't have long in that, right? So it depends on what programming language you choose for coding. C++ or Java, you can go with any one of them. And if you're good at Python, it's okay. You can go with Python as well. But mostly C++ or Java is preferred by most of the people, right? So you can go for it. Or if you want to go with Python, you can go for it. So let's try to learn something more about this. Like there is something called as bytes. What is this bytes? Bytes in the sense, you know it. You know what is a bit, right? It's a small box. If you take a small box, it's a bit. That means you can store a bit of data in that. Then what's a byte? Simple. Byte is nothing but it's of 8 bits. So 1 byte is 8 bits. This is a basic thing, most of the people know. If you are in the computer, programming background. If you don't know, it's okay. So generally we try to store this data, whatever data, like if you have an integer or you have some character, whatever it may be, you basically store them in something called as bytes or a bit format. Generally bytes is the thing that you're going to describe, right? So here also we are doing the same. If you are having, let's say you have an integer which is 4, if you want to store this 4 in the memory, it's not like you create a box for it and you just store it as a 4. That's not the thing. There is something different for it, right? So if you don't think like this, you integer, this is an integer and something 4 will be stored here. No, it's not like that. Basically, for integer, it's of 4 bytes. That means you will be having a 4 bytes of memory where you are going to store it, right? So that is the idea. It's not like you're completely storing that number in a box. No, you are trying to store that integer 4 in a computer understandable format, not in your understandable format, right? Generally computer don't know what is this 4. Computer knows only what? Zeros, ones. Being practical, computer knows only 0 and 1. It doesn't know anything more than that. So this 4, what you're doing? You're doing something then to convert this 4 into a binary format. That means into a format which is of 0 or 1. So generally how you can write 4? Can you tell me? It's very simple. Firstly 0, again 0, and then 1. Right? This is what? This is of 1 and this is of 2. Finally this is 4. It's something like 2 power 0, 2 power 1, 2 power 2, like this, right? And it goes on, right? So generally 1 0 0, this is actually stored in your computer as a part of storing this 4. It's not like 4 is directly stored. And I think you have some basic idea about binary representations, decimal representations. Generally what we have done here is we converted a binary number, a decimal number into a binary number. Decimal number is basically the things that you understand, but binary number, it's basically the computer will understand, right? So computer knows only this ones and zeros. So that is the story about this thing. How basically when you create something like int a equal to, let's say, 5. So if you write this statement, basically this thing happens, right? So it's as simple as that. So as I said, integer is of 4 bytes. Similarly, float is also 4 bytes. And if you take character, it's only of 1 byte. If you take a part of Java, it's 2 bytes, but C++, I'm talking relative to C++. If you take with respect to C++, then it's of 1 byte. Generally, character is nothing but, like A, B, C, like these things, right? So it requires only 1 byte. And Boolean is also of 1 byte. Double is something which is of 8 bytes. As I said, double will try to store more decimal places than float, right? Than float, double will store more. So that's why it has a more, memory limit, or you can say memory size, 8 bytes. Similarly, you have long double, which is again more than that, which is 16 bytes. And you have long, which can be 4 or 8. It depends on, the type of compiler that we are going to use, but it's pretty simple. Let me erase this thing. So long can be a 4 or it can be a 8. It depends on the compiler, like it's 32-bit compiler or 64-bit compiler. So just want to tell something about compilers. You can visit my C programming. I've discussed in detail about the compilers part. Like I've discussed everything related to computer, what happens in computer, what is a compiler, what is an interpreter, these things. Okay, so please you can go to my channel and watch those videos. And you have short, which is smaller than it, which is of 2 bytes, and similarly you have long as well, which is of 8 bytes, which is taking more than integer. So that is about some basic idea about this, data types. Integer, float, you know this double, and this long. These are very important things you might have used many times in your programming. If you are doing programming in C or C++ or Java, whatever it may be, definitely you could have used them, right? It's compulsory to use because you generally use it in your whatever tasks that you are doing or whatever the program that you are typing, right? So that is some basic thing about data types. Now let's go deep into it. Okay, let's try to know. As I said, you have integer, right? What I said, integer is of 4 bytes. It's okay, 4 bytes, it's cool, right? Let's try to see what is the limit. That means if you declare an integer, that something like int a equal to something like 5, you want to know, is it okay if I write here 5 or not? Generally 5 is okay because 5 is an integer. But if you try to write some bigger number, like let's say 1 2 5 6 1 2 3, something like this you have written instead of 5, do you think will this variable a will hold this thing? You don't know, right? Basically the answer is you don't know. So what we are going to do is we'll try to see what is the range, that means, or what is the limit that integer can handle. Like what is the lowest limit that an integer can handle, and what is the highest limit that the integer can handle. If you know these things, then you, while programming or whatever you do, you will be cautious. Like, okay, when I'm declaring int a equal to some big number or whatever number, okay, I know integer is of this range, so I don't need to declare this number. I mean, it means that I need to use something bigger than that number. I mean, bigger than the integer, right? So that is the idea. Let's try to check it out now. Let's take a 2-bit representation. 2-bit. 2-bit is in the sense you have only two spaces. That means you have 0 and 1, and you can occupy 0 and 1 in these two spaces in how many ways possible. You can check here 0 0, 0 1, 1 0, and 1 1. So these are the maximum, and these are the only possibilities that you can check here, right? So 0 0, 0 1, and 1 0, and 1 1, right? Now, what is the value of this representation? 0 0, it's 0. So basically here you have something new, like what is this signed and what is this unsigned, right? If you are good at programming, then definitely you could have find it, right? And if you have watched my C videos, then definitely there is no doubt in knowing these things. Basically, in programming, you can store positive numbers or you can also store negative numbers. It's not like negative numbers will stored as a negative number, but it will also be converted into a 0 and 1 format. Okay, if you have 5 and if you have -5, don't think that, let's say for 5, what is the representation? For 5 the representation is 0 1 0 1. Is it correct? This 2 power 0, it's 1, and this 2 power 1, it's 0, and this 2 power 2, 4. 4 plus 1, it's 5. Okay, hope you don't have any doubt. Then what is -5? Do you think this -5 is also stored at this location only? If that happens, then if you want to retrieve the value from that location, then you will get -5. If -5 is also stored in that location, then there is some ambiguity, right? So there must be some different representation for this -5 as well, isn't it? So that is very important. You need to know it. That means you need some alternate method so that you want to store this -5 as well in your memory. So for that thing, you can use something called ones complement. You could have heard it, right? Ones complement. Generally what we'll do, we will try to find out the binary representation, and we'll try to add one, we'll try to negate that binary representation. That means if you have something like 0 0 1 0, then we'll try to negate this. Negate in the sense we will try to complement each and every bit. Like 0 is there, right? We will try to write it 1. Again 0, you will 1, you will do it as 1. For 1 you will write 0, for 0 you will write 1. That means this thing is entirely changed into what? Opposite of it, right? So after complementing this thing, we will just try to add 1 and you will get a new representation. And in this new representation, whatever the first suppose you have some new representation like this, let's say like this, then whatever the first bit is there, right, you might have seen it, this is the most significant bit, and this bit will generally represent what? It will represent your sign, whether it's positive number or whether it's a negative number. If it is 1, then it's a negative, else it's a positive number, right? So I don't want to explain these things because as a part of programming, you could, max, as a part of max, in this binary representations, you could have heard it many times and you have a good grip as well, right? So there is nothing, those things that you need to know here, but let's try to learn this. For this 0 0, you are writing unsigned as 0. That means unsigned in the sense it's positive, right? And signed in the sense there is some sign. Let's say there is some negative sign, okay? Because there is only one sign you have, that's a negative sign. So 0 0 is for this thing, and 0 1, you know it, right? So 0 1, it's 2 power 0, which is 1, so it's 1, right? And 1 0, it's 2 power 1, so 2, that's why you have 2 here. You have 1 1, that means 2 plus 1, which is 3, right? And these are the negative representations. Okay, for 1 0 it's minus 2, and for 1 1 it's minus 1. So don't I hope you know how you got these things. Like as I said, you are going to take one's complement of it. Firstly you need to negate this, that means you need to complement these bits, and then you need to add one's complement and check it. Okay, so let's try to see 1 0, you try to negate it, it becomes what? 0 1, then add 1 to it, something like this, right? 1 plus 1, it's 1 plus 1 is not 2. Okay, I think you know it, right? So I'll do something called as negation here. Okay, so and then it's a representation of 2 and it's a minus negative sign, right? So I just I hope you know it. So that is the representation of these things, right? Now, so why we have done these things? I said it's a 2-bit representation. I'm going to explain. Basically, I did not give an introduction to it. So why we are doing it? To find what? To find a range. Okay, so this is the representations. Sorry, these are the representations, and these are the values for those representations. So these are the only 4 ways. There are only 4 representations for it because it's a 2-bit, right? So for unsigned, tell me what is the maximum, maximum value. For unsigned, the maximum value is 3. So that's why I've written here 3. And for unsigned, what's the minimum value? It's 0. That's why I've written here 0. Hope you got it, right? Similarly for signed, what is the maximum value? It's 1, right? Because negative numbers are of minimum, right? So I have written here maximum. And what is the minimum value? Minimum value is minus 2. So that's why I have written here minimum minus 2. So the first one in this brackets, whatever I've mentioned, the first one is of minimum and the second one is of, so first one is of minimum, second one is of maximum. So basically why I am telling this is for a 2-bit representation. Okay, for a 2-bit representation, if you take an unsigned thing, that means let's say if you take an unsigned integer can be of 2, right? It can be signed or unsigned. If you take unsigned integer for a 2-bit representation, right, then you have only the minimum value to choose as 0 and the maximum value to choose as 3. That means you cannot go less than this and you cannot go greater than this. This is a fixed limit for what? For unsigned integer of 2-bit representation. So similarly, for a signed integer, let's say for a signed integer of a 2-bit representation, again I'm repeating, for a signed integer of a 2-bit representation, the minimum value is -2 and the maximum value is 1. That means, let's say 1 point here you have -2 and 1 point you have here 1. You can choose only values that are in this range only. That means you cannot go less than this or you cannot go greater than this. Similarly here also, right? 0 and 3. You cannot go less than this or you cannot go greater than this. Whatever the values you give for that unsigned integer, you give only in this range. You might be getting one doubt. I'm saying int a equal to 5, but you are telling only 0 to 3 is the range. Wait, it's a 2-bit representation. It's a 2-bit representation, right? What is integer? Integer is of how much? I said only as an example, as an unsigned int. But actually integer is of how much? It is of 4 bytes. It is of 4 bytes. That means this integer is of how much? 4 into 1 byte is 8 bits. So this integer is of how much? It's of 32 bits. That means instead of 2-bit representation, you want a 32-bit representation to know this minimum, to know this limits for unsigned and signed integer, right? So you need to do the same thing for 32-bit representation, okay? But let's try to learn something more about this, right? So let's try to clarify it with the another 3-bit representation. Previously, we have seen for 2-bit, right? Now let's try to check in the same thing for 3-bit representation, right? Same thing, 3 bits in the sense you have 3 slots left, right? So in these 3 slots, you can have either 0 or you can have either 1. So you can see clearly. I have got how many representations? I have got 8 representations. So there is something like if you have a 2-bit, it's of how much? 2 power 2 representations. If it is a 3-bit, then it's how much? It's of 2 power 3 representations, right? It's a 4-bit, then how much? It's of 2 power 4 representations. So that's why previously we have got 4, right? For 2-bit we got only 4, 4 things, right? 4 representations. So that's the thing here also. 3-bit, here you got how many? 1, 2, 3, 4, 5, 6, 7, 8. It's including 0, right? That's why you got 8. So that is the idea here. So similarly you got the representations here, and for unsigned, that means for unsigned thing these are the values, and for the signed thing these are the values. Similarly here also from 100, it's a 4, but 100 how we are telling -4? It's based on the complement thing, like one's complement I have said you, right? So based on that thing you are writing it. Now for this unsigned, let's say integer, let's say something like that, let's say, okay, it's not like an integer, but let's say for this unsigned thing, what is the minimum thing? Minimum value, it's 0. Minimum is 0, right? What's the maximum value? It is 7. You can clearly see. Similarly in this signed, these thing also, this list also, minimum value is -4. You can clearly check -4 is the least one. You have 0, but you have negative values as well, right? So the maximum is 3 because there is nothing more than 3. Okay, so that is the range for what? 3-bit representation. For 4-bit representation, for unsigned this is the range, and for signed this is the range. Okay, don't try to remember these things, I'll make you clear how you got these things. Okay, and similarly for 3-bit, this is for unsigned, particularly 3-bit unsigned, this is the range, and for 3-bit signed this is the range. Hope it's clear, right? Now what we are going to see, I have written the same thing that we got previously here. Okay, you can clearly check for unsigned, this is the range. For what? Unsigned what? This is 2-bit representation. Okay, and this is for 3-bit representation, right? So what I'm going to tell you is, for 32 bits you want to do, right? Previously we have done for 2 bit and we have done for 3 bit as well. But integer is actually of 4 bytes. That means integer is actually of 32 bits. So I want to know what is the range for integer. For unsigned int, I want to know the range similarly like this. And for signed int also, I want to know range something like this. Just like how I got for 2 bit and just like how I got for 3 bit. I want to know for 32 bit. What is the range, right? I want to know for the 32 bit, right? Now, you can clearly check for 2 bit, this is of 2 bit and this is of uh, 3 bits, right? Now, there is something you can check here, 3 and 7. 3 is nothing but 2 power 2 minus 1. You can write something like this, 2 power 2 minus 1. And similarly 7 in the sense, it is 2 power 3 minus 1. That means 4 minus 1 is 3 and 8 minus 1 is 7, right? So you got some, a formula kind of thing, right? You got 0 comma 2 power whatever the number that you have minus 1. That means you have 3, right? Here I've said 2 power 2 minus 1. That means 2 power n minus 1. N is your number. If n is 3, it is 2 power 2 minus 1. And if n is 7, if n is 3, if n is 4, then it's 2 power 4 minus 1, right? So you got something like 2 power n minus 1, right? So there is something, a formula that you're getting here, right? So you can check here, I'm telling you in detail here. If you take an unsigned int, the range will be of 0 comma 2 power, here it is of 32 bits, right? It's 2 power 32 minus 1. Simple. Similarly for a signed int, is there any formula for signed int? Can you tell me? Left side you have powers of 2, that means 2 power 1, 2 power 2 something. Right side you have what? 1, 3. What does this mean? 1 in the sense 2 power 1 minus 1. 3 in the sense 2 power 2 minus 1. That means here also you have something which is of power of 2 minus 1. So similarly here also left side is what? It's left side, it's of powers of 2 minus powers of 2. So that's why I've written minus 2 power 31, and right side is how much? 2 power 31 minus 1. Hope you got some idea, right? That is the basic thing that I wanted to tell you, why you got this range. Okay, based on this thing, I'm just based on these two, whatever we have solved earlier, based on those two things, we are trying to find out the range for integer, which is very interesting, right? Basically, we'll try to remember whenever we want to know what is the range for integer, we'll try to remember it. But here you can clearly see how easily we have done it, right? Now, these are very important for us. We got to know range, right? We got to know what? Our range. Don't think you might be getting a doubt. Here it's 32, here it's 31. I can tell you here, you can check it's 3 is nothing but how much? 2 power 2 minus 1. That means for 2 bit representation, it is of 2 power n minus 1. That means 2 power n bits minus 1. So similarly for 32 bits, it's 2 power 32 minus 1. That's why you got here 2 power 32. But for, this thing, for this thing, you can check it's 2 power 1. It's not 2 power 2. For 2 bit only, it's 2 power 1. So you got 1 bit, one number less. That's why I have written here 2 power 31. Okay, it's 2 power 1, right? It's not 2 power 2. Here you got 2 power 2 minus 1. But here you got 2 power 1. That means 2 power n minus 1 you got. If n is 32, it is 2 power 32 minus 1, it's 2 power 31. So that is the idea. That's why I've written here 2 power 31. Okay, don't get confused. So it's very important that if you try to do this 2-bit and 3-bit representations, it's very easy, you can find it out, right? There is no issue. You can just hold on paper and you can try to solve it, you'll get it. Now I'm doing something more interesting thing here. As I said, these are important for us. We'll try to make it more simple, right? I've written something called as 2 power 10 equal to 10 power 3. What does this mean, right? Generally, 2 power 10 is what? How much? Can you tell me? 2 power 10 in the sense it's 2 power 5 into 2 power 5. 2 power 5 is how much? It's 32, right? So 32 into 32, you will get something 1024. 2 power 10 is 1024. This is something close to 1000. Of course, it's there is something 24 more than 1000, but you can write this 1024, this number, this entire number. Let me erase it. You can write this 1024 as 10 power 3. Close, somewhat close. It's not exact, but we will try to approximate it. That means if 2 power 10, right, 2 power 10 is nothing but 10 power 3, right? Then 2 power 20 is how much? Simple. 10 power 3 whole square. That's it, right? 2 power 20 is 2 power 10 square. 2 power 10 is 10 power 3. So 10 power 3 square is 10 power 6. Then what is 2 power 30? Simple. 10 power 9. 2 power 30 in the sense 2 power 10 whole power 3, right? 2 power 10, you know what is 2 power 10? 10 power 3. So 10 power 3 whole power 3, which is 10 power 9. That's why I got here 10 power 9, right? So what I am trying to tell is 2 power 10 as 10 power 3, then 2 power 32. 2 power 32 you can approximate, right? You can try to approximate it to somewhere around 10 power, somewhere around it, somewhere around 10 power 9. So that's why I'm trying to write this as 0 to 4 into 10 power 9 minus 1. Okay. So we are trying to approximate it. Why I have written here 4 is 10 power 9 is what? It is of 2 power 30. But you have 2 power 32, right? That means you have 2 power 2 extra. That means 2 power 30 into 2 power 2 is 2 power 32. 2 power 30 is 2 power 10 power 9. We've seen, right? Then you need to multiply this 10 power 9 with what? With 4. So that's why I've written here. That's why I've written here 4 into 10 power 9 minus 1 is as it is. Right? So it's very simple. Similarly, here also we are writing the same thing. 2 power 31, you are writing minus 2 into 10 power 9. Why you have used here 2, here we have used 4. It's very simple. You can tell it, right? It's 2 power 32 here, but here it's 2 power 31. And previously I have told you, right? Why here it's 2 power 31 and why here it's 2 power 32. Here we got 2 power number of bits minus 1. This is of 2 bits, right? So number of bits minus 1. But here you got number of bits. Number of bits itself is subtracted by 1. Here 2 power 2, which this thing is subtracted by 1. But here 2 power 2, this power itself only subtracted by 1. So that's why here we got 31 and here we got 32. Okay. So don't try to confuse here. I just want to tell you one thing. Basically this is unsigned and this is signed, and there is small mistake from my side. Okay. Similarly this is unsigned and this is signed. Okay. So don't get confused here. Okay. And this this part, this first block is of 2-bit representation and the second block is of 3-bit representation. Okay. Now as I said, we have converted this important thing which we told just now into this thing. Okay, so just wanted to normalize it. Okay, it's very simple. Now you got what is the representation for integer. Let's say someone asks you what is the representation for integer. You need to tell this thing because integer. Sorry. What is the representation for integer? Then you need to tell this thing. Basically, integer itself, you will generally think it of unsigned, right? If they specifically mention you what is the representation, what is the limit for signed integer, then you need to tell this thing. So once again, I'm repeating. For unsigned integer, this is the range, and for signed, this is the range. Simple. No need to get uh, doubt how you can remember it. I've made it easy. Just try to write down. Don't write 3-bit representation. Just write this 2-bit representation and try to note down these things. From this only you can get it, right? So your 3 you can write 2 power 2 minus 1, and this 2 you can write 2 power 1, and 1 you can write 2 power 1 minus 1. Okay, so just try to hold pen and paper with you so that you can practice with me. It's very simple. So that is for integer. If you are doing for integer which is of 32 bits, then can't you do it for many other things? Yes, you can definitely do, right? You can do it for int. I have told you for int and unsigned int. You try for float from your side only. Basically, float is also of 4 bytes. That means whatever you get for integer, same thing you will get for float as well. Right? Similarly, double, which is of 8 bytes. You can check I have clearly mentioned here bits as well because you need to do those representation with respect to bits. Okay. So here I have normalized something like this. Integer range is minus 10 power 9 to 10 power 9. Its long is of minus 10 power 8 into 10 power 8. You don't get doubt, right? So why I have written int as 10 power 9? Because you got int is of 10 power 9. Integer you got something which is a change of 10 power 9, right? So it's multiplied with something, but you got integer which is of 10 power 9. So that's why I have used 10 power 9 for integer, and for long, which is long is double the integer, right? So that's why it is of 10 power 18. Okay, so basically these two things will be very crucial when you're trying to solve the problems where you will be given constraints, right? In problems they'll mention the constraints, and based on that constraints you can decide whether you need to take an integer or whether you need to take a long. Understand? If in constraints they have mentioned 10 power 8 into 10 power 18, then there is no chance that you take integer, because if you take that you cannot store that long value, because constraints they have mentioned clearly you need to use the long. But if you use this integer, then definitely you will get some errors, right? Let's try to learn about those errors in our future videos, but just try to remember these things. There is nothing to remember because I've told you these things how you got with proof, right? And these are the ranges you can check in detail ranges as well I've given here, right?